Hello, Orange Glen. This is Mrs. Sorrow. It's going to help you simplify rational exponents. Just to remind you, rational is just a fraction, exponent's just a power. And so, even though we covered all these properties before, we're going to focus on what happens when these exponents are fractions. Just to remind you, an exponent by default is just another way of talking about how to rewrite the base form. And so most of the time when the exponent is a fraction, it's actually a radical. And if the divisor is something other than 2, we actually have to list what that is, like a cube root. We have to write a 3 up in here. Other than that, it's a square root, because if it's not identified, it has to be a square root. So we're going to go ahead and scroll down. We're going to go over some of the examples that we have here today. We're going to actually just zoom in on each part of these so that I have enough room to show you exactly what I want you to do with that exponent. So for A, we can clearly see that the exponent is negative 1/4. Now we're going to do two things at once here. We're going to actually do the distributive value, which is part 3. But when we distribute to a base that already has a power, we're going to distribute it and multiply by the existing power that's there. So this negative 1/4 is going to go to both the 4 from the 2 and the 4 from the base of 3, and we're going to multiply these two together like so. Okay. We're just going to rewrite that. Of course, 4 times negative 1/4 is going to give us 1, or negative 1. And it happens the same for the 3 over here. The negative powers, we're actually going to do problem number 4 right over here in the properties. And we see that it becomes one big fraction, where now the powers are happy, and it becomes 1 over 2 times 3, which happens to be 1/6. Now we're done with problem A. I hope that was not too bad. Let's go ahead and move down to problem B. Okay. Now we see that it keeps the radical. This is a cube root because of the 3 right here. So we can actually rewrite this as 125y to the 6th power divided by 8x cubed, all to the power of 1/3. Now, there's some things that we need to know. We're still going to distribute like we did last time, but it's going to be more like property 6 because we're going to distribute to both the numerator powers and the denominators to each base. We're going to distribute to 125, we're going to distribute to y, to the 8, and to the x. Now, something that we have to keep in mind, numbers actually are hidden powers. In fact, 125 and 8 are cubes. They're cube numbers. So in case you forgot or you didn't know, 125 is 5 cubed and 8 is 2 cubed. So I'm going to use these facts. I'm going to rewrite these numbers, and then I'm going to distribute the 1/3 to each. So now we have this right over here. When I do this, I can either divide them right away and rewrite it, but I thought it would be nice to show you that when we multiply a number by a fraction, we can just multiply the numerators together, and we get easier fractions to see right here. And of course, 3 divided by 3 is 1, 6 divided by 3 is 2. So we're just going to simplify that one more time. And we see that we have 5y squared over 2x. This is the most simplest form for this crazy radical exponent. Now it's actually not that bad. With this said, we're going to go ahead and move down to C. Again, the square root, because there is no number here, is going to be 1/2 power. Now the 48 isn't a cube root or a square root of some kind. We actually have to do the factor tree. Now, in this case, I thought 4 times 12 is 48. 4 is 2 times 2, 12 is 3 times 4, and then I can break down the 4 into 2 times 2. This is all the small factors of 48. We have 2's, we have 4 of them, we have 1, 3, and so I can actually rewrite this 48 as 2 to the 4th power times 3. So I'm just going to go ahead and write that down. 2 to the 4th power times 3 times x to the 10th power. Okay. Now that I dealt with a crazy number, I can do the property here in problem number 3 and 4. The property is right over here. I'm going to distribute the 1/2 to each part. And if it has a number like 4, I'm going to actually multiply the fraction with the number up here. Since 3 doesn't have a displayed number, it automatically gets the 1/2, and 10 times 1/2 right over here. We see that we have this, and then we're going to multiply them. We got this, and 4 divided by 2 is 2, 10 divided by 2 is 5. And now I'm just going to rewrite it one more time, because obviously we could have kept it this way. Both of these are valid answers. This is just the most simplified version right here. Okay. Last but not least, the example from the rational exponent area. We see that we have the cube root of -8. Now, I know a lot of us know that square roots can have negative numbers. It's imaginary. It's impossible. A number times itself can never be negative. But the beautiful thing about cube roots is that cube roots can be negative because we're multiplying by 3 separate numbers. Right? So we're just going to rewrite that cube root to 1/3. And we actually can see that -8 is -2 times -2 times -2. So this actually works out, and it is la-di-da and -2. It's the only case any odd number right here can be negative on the inside. All even numbers can't be negative because there's no way multiplying it in an even set like -2 times -2 has to be positive. But if it's odd, like you're multiplying it 3 times, it can keep that negative value and not be imaginary. That was just a fun fact. Okay. Now we're going to move on to actually adding, subtracting, multiplying fractions. This is on the other side of the note paper that I gave you before. The first step we're going to do is we're going to completely factor the numerator and denominator. Okay, so when we do that, I'm just going to zoom in now. We're going to actually look at the numerator, which is this. And I'm just going to do what I normally do. I look at the 1. I know it's positive, so I'm going to add the factors. And the only thing that can multiply to get 1 is 1 times 1. And 1 plus 1 happens to be 2. So we're good. So now I know that's going to be x plus 1 times x plus 1. And this is my factored form. I actually want just to leave it like this. Now I need to find the factors of the denominator. So x squared minus 1. X squared is a squared number. It's x times x. Minus 1. 1 is a square number. We just see it right here. 1 times 1 is 1. Okay. So we actually can use the difference of squares. And we have x minus 1 times x plus 1. And that will give us this property. So now I'm just going to rewrite this. And I'm just going to have the factors in place of these non-factored forms over here. Okay. I can see that these two are the same, and so I'm just going to eliminate them. And I have x plus 1 divided by x minus 1. is my simplified fraction form, and I'm done. So the hardest part of this was actually knowing how to factor the numerator and denominator in order to cross out like factors to get the simplest form. Okay, so B has its own problem. If we look at it, we need a least common denominator. As you can tell, the least common denominator has to be the same. These two are completely different, absolutely different. So in order for them to work, we need to multiply both sides by the opposite denominator. Now, when we multiply them, we actually need to multiply the numerator and denominator by the other denominator. And we need to do it to both of them so that they have the least common denominator, x times 3x minus 2. Okay. So now I'm going to be distributing the numerators together. Okay, so just to make it short, because they have a least common denominator now, because we multiplied this, we can actually put it in one solid fraction right now. So 6 times x is just 6x, but we actually didn't multiply this out yet. 5 times 3x, 5 times negative 2 is 15x minus 10. And then now we can combine like terms. We add these two together. We get a wonderful 21x minus 10 for the numerator. The beautiful thing is the denominator usually doesn't change after we simplify forms. And we're done. Once we are able to distribute and combine like terms, we are done. So that is everything actually for the notes. So on Monday, don't forget to bring the practice, okay? Because the practice is what we're going to do in class. I recommend reading the I recommend reading the I recommend reading the properties for fractions, and I recommend reading the process in the practice. Don't worry. Okay. Have a beautiful night and rambling now. Peace.